Morning. Mhm. Morning, everyone. A very warm welcome to all who have joined us today for the inaugural session of the International Conference on Advancements in Materials and Machining with Artificial Intelligence Applications, ICAMMAIA 2026. I'm Nida Rahman, and I'm Isha Anand from the Mechanical Engineering Department, and we feel immensely pleasure to be your host for today's event. The conference, organized by the of mechanical engineering is a platform to bring together researchers, industry experts, and architects and academicians to exchange knowledge and innovations in material science, advanced manufacturing technologies, and artificial intelligence applications. Executive Campus has been a beacon of excellence since its inception in 1921. Upgraded to a university in 2016, HBTU has remained committed to fostering research, skill development, and technical advancement across multiple disciplines. Hosting ICAMMAIA aligns with our mission to drive innovation and push the boundaries of engineering and technology. This hybrid mode conference is designed to explore cutting-edge advancements in biocompatible materials, nanotechnology, automation in manufacturing, renewable energy solutions, AI-driven manufacturing applications, and much more. The next 2 days, we'll engage in thought-provoking keynote sessions, insightful coding presentations, and interactive discussions that will shape the future of these days. By organizing this conference, we aim to provide a dynamic forum for industrial professionals, researchers, and scholars to interact, share experience, and discuss recent challenges and solutions in mechanical engineering and associated disciplines. We're honored to have eminent personalities with us today who have contributed significantly to these domains. Without further ado, let us commence this remarkable conference by inviting our distinguished guests to the dais. We kindly invite our Honorable Vice Chancellor, Professor Samsher sir. Can we have a huge round of applause for him? We also extend a warm invitation to our guest of honor, Dr. Vipin Chandra Shukla sir, Scientist G, Ministry of Science and Technology, New Delhi. Next, we welcome Professor Vinay Pratap Singh sir, Head of Department Mechanical Engineering and Dean of School of Engineering, to join us on the dais. We now request the conveners of this prestigious conference, Dr. Yashvir Singh sir and Professor Nishant Kumar sir, to join us on the dais. Finally, we would request Dr. Rohit Kumar sir, Coordinator ICAMMAIA 2026, to join us on the dais. To commence this conference on an auspicious note, we now invite our guests to join us for the lamp lighting ceremony, symbolizing wisdom and enlightenment. May this light inspire innovation and meaningful discussion throughout the conference. The divine blessings of Goddess Saraswati, the embodiment of wisdom, knowledge, and creativity. I can invite our esteemed guest to our closest beauty goddess Saraswati. So, as a mark of love and respect, we request Professor Vinay Pratap Singh sir to welcome our chief guest, Honorable Vice Chancellor Professor Samsher sir. Please be the proud of we request Professor Nishant Kumar sir, convener at ICAMMAIA 2026 to extend a warm welcome to our guest of honor, Dr. Sharma Shukla sir. Dr. Rajiv Kumar Upadhyay sir to please join us on the dais. Can we have a huge round of applause for him? The first Professor Yashwini sir, convener, welcome our guest Dr. Rajiv Kumar Upadhyay. Everyone, give a huge round of applause. Thank you, sir. Now, we kindly request Dr. Rohit Kumar sir to welcome Professor Vinay Pratap Singh sir. We kindly request all the guests present on the dais to inaugurate the proceedings of this conference. So, give a huge round of applause. us an insight into the Department of Mechanical Engineering and the School of Engineering, we now invite Professor Vinay Pratap Singh sir to kindly address the gathering. So we kindly request you to take the stage and share your words with us.
Good morning to all of you. Dear Honorable Vice Chancellor, guests of honor, to Vishnu Scientist G, Ministry of Science and Technology, New Delhi, distinguished guests, Dr. Rajiv Kumar Bhatia Ji, Director, KNIT Sultanpur, eminent speakers, esteemed faculty members, deans, research scholars, participants, and dear students. A very warm welcome, all of you, to this prestigious international conference on advancements in materials machining with applications with artificial intelligence applications. It is indeed a moment of great honor and privilege for me to address this august gathering on such an important occasion. At HBTU, we take immense pride in being a center of academic excellence and innovation. Royal University has always been at the forefront of technological advancements, fostering research and development across various engineering disciplines. And this today's conference is yet another milestone in our commitment to academic and industrial excellence. I'm here in capacity of Dean School of Engineering as well as Head Department of Mechanical Engineering. So I'll be talking about both. Now, School of Engineering came into existence in 2016 since the inception of HBTU from HBTI. It has five departments: mechanical, civil, electrical, electronics, and computer science. And all the department offers undergraduate, postgraduate, and PhD programs. Our curriculum is designed to provide a strong theoretical foundation complemented by practical exposure through state-of-art laboratories, research projects, and industry partnership. We emphasize innovation, interdisciplinary learning, and problem-solving skills, ensuring that our students are well equipped to tackle real-world challenges. Our university is NAAC A+ accredited, and almost all engineering departments are NB accredited, all due to the visionary leadership of our Honorable Vice Chancellor sir and hard work of all the departments. Our faculty members and researchers are actively engaged in cutting-edge research in fields such as artificial intelligence, IoT, smart grids, sustainable energy, smart materials, and advanced manufacturing technologies, and so many. Beyond academics, the School of Engineering is committed to the holistic development of the students. So we encourage their participation in technical clubs, hackathons, innovation challenges, and extracurricular activities, fostering a culture of creativity, leadership, and entrepreneurship. Our graduates have gone on to excel in prestigious global companies, research institutions, and entrepreneurial ventures, carrying forward the legacy of HBTU. Now, coming to the Department of Mechanical Engineering, this department was established in 1964. At present, we are offering three programs: BTech in Mechanical Engineering with a sanction intake of 60, MTech in CAD with sanction intake of 18, and PhD program. So we are accredited by NBA, and we have a very strong faculty members. We have present, we have 17 faculty members are all very qualified. If you talk about the alumni, we have a very strong alumni base. We have administrators, we have entrepreneurs, we have very good academicians. Even our beloved Honorable Vice Chancellor is also the alumnus of the department. Our faculty is involved in cutting edge research in the field of robotics, 3D printing, computational fluid dynamics, composites, biomaterials, and so many more. We have a very good placement record. Students are encouraged to participate in research, internship, and technical projects that enhance both their practical knowledge and innovative thinking. In essence, mechanical engineering students are not just learners, they are the future innovators, researchers, and leaders who will change the technological landscape of tomorrow. Now, coming to the conference, in today's rapidly evolving technological landscape, the integration of advanced materials, precision machining with artificial intelligence is redefining the boundaries of engineering. Material science is enabling the creation of lighter, stronger, and smarter materials, whereas machining technologies are achieving unprecedented accuracy with efficiency. And artificial intelligence is transforming the way we design, manufacture, and optimize systems. This conference serves as a vital platform where academia meets industry and ideas transform into innovations. It provides an opportunity for researchers and practitioners to share their insights, discuss challenges, and explore collaborative solutions for real world problems. I express my sincere gratitude to the organizing committee for their dedicated efforts in making this conference possible. I also thank all the keynote speakers and experts who have taken time from their busy schedule to share their valuable knowledge with us. To all participants, I encourage you to actively engage in discussion, present your ideas confidently, and make this the most of this academic gathering. The true success of this conference lies in the meaningful interaction and the exchange of knowledge. With these words, I once again welcome you all and wish the conference a great success. Thank you.
Thank you so much, sir, for your insightful words and highlighting the department's contributions and visions. Moving forward, to provide us with an overview of the theme of this conference and its significance, we now invite Dr. Yashvi Singh, sir, convener of the conference, to share his insights.
Thank you. Very good morning to our Honorable VC sir, to our eminent speaker, Professor Rajiv Kumar Upadhyay, and our guest of honor, Dr. Vipin Chand. And I'm also thankful to all the participants and the industries who are here for the discussion during this conference. It is my privilege as the founder of this international conference on advancements in materials machining with artificial intelligence applications to present an overview of the central themes and define this conference and highlights its academic and industry relevance. The field of materials machining has undergone remarkable transformation over the past few decades. Traditionally driven by empirical knowledge and manual expertise, it is now evolving into a highly intelligent data-driven domain. The integration of artificial intelligence into machining processes is not just an advancement, it is a paradigm shift that is redefining manufacturing systems worldwide. The core theme of this conference revolves around the convergence of material science, machining technologies, and artificial intelligence. This interdisciplinary approach opens new avenues for innovation and efficacy. One of the key focus areas is smart machining, where AI techniques such as machine learning and deep learning are used to optimize cutting parameters, predict behavior, and improve product quality in real time. The conference also emphasizes predictive maintenance and condition monitoring. By utilizing AI algorithms and sensor data, industries can anticipate machine failures, reduce downtime, and improve overall productivity. This is not just only enhances operational efficiency, but also contributes to cost savings and resource optimization. We are also focusing on sustainable and green manufacturing practices. AI can play a vital role in minimizing energy consumption, reducing material wastage, and promoting environmentally responsible machining processes. This aligns with global efforts towards sustainable industrial development. Through keynote lectures, technical sessions, and discussions, this conference aims to bring together diverse perspectives from academia and industry. It provides a platform to share cutting edge research, exchange ideas, and build collaborations that can shape the future of intelligent manufacturing. I strongly encourage all participants to actively engage in these sessions, ask questions, and explore opportunities for collaboration. The true success of this conference lies not only in knowledge dissemination but also in the meaningful connections and ideas that emerge from it. In conclusion, the theme of this conference reflects the future direction of manufacturing, smart, sustainable, and AI-driven. I am confident that the discussions over the course of this conference will contribute significantly to advancing both research and industrial practice. Thank you all for your presence and participation. I wish you all a productive and insightful conference. Thank you.
Thank you so much, sir. Your words have set the stage for meaningful discussions and innovations in this field. Moving forward, I would like to give you all a brief profile overview of our guest of honor, Dr. Vipin Chandra Shukla, sir. Dr. Vipin Chandra Shukla sir is currently serving as a scientist G in the Department of Scientific and Industrial Research, Ministry of Science and Technology, Government of India. And I request Vipin sir to kindly share his insights with us. So can I please have you on the stage?
Hi, good afternoon, good morning to everyone. Honorable Vice Chancellor Subshare, Professor Bajaj, and the whole team on the dais, mechanical engineering department professors, professors, faculties of the dais, students, youngsters. So, first of all, I will thank to the organizers because they have given me this opportunity to stand in front of all of you. Uh, Probably I thought still introduce and then you will come to know that I'm also alumni of this institute. So let me tell you that I was uh, long back a student of this institute in mechanical engineering department itself, and it's really very nostalgic for me to come here, especially when I'm in this auditorium. You know, when I was 4 years old, at the time I came to this auditorium in 1977, right? So you can understand I have a belongingness of around 50 years with this HBTI, HBTU. And those were the days when some movies were screened here, and my Mamaji was a student of this institute at the time, and he brought me on his shoulders. And I watched the movie at the age of 4 years in this auditorium in 1977. So I'm the most oldest person you can say as far as the belongingness to the institute is concerned. So that is the nostalgic feeling for me. And I don't know the correct word for that, but let me say कि मैं HBTU को नमन करना चाहता हूँ. That is my from the core of heart. Whatever I am here because of HBTU, and I know that lot of potential is lying in youngster also. So I will not go into the legacy which HBTU is having with its past. And if you keep on exploring the facts, you will come to know a lot of eminent people across not only India but also globally. They are from HBTU. So that kind of confidence you keep in your mind whenever you focus to make your growth in career. Now, because I have to talk something, but I'll be a little bit informal also because I know that I have long association. So what I'll talk to you right now that youngsters they should now take the lead and how to create an entrepreneurial spirit, how to create an ecosystem of startups at your institute. Right? I'm not academician and I am not pure researcher. So you will listen only uh, relevant things for your career perspective, which are being focused by government of India. So startup and this entrepreneurial spirit capacity building is being promoted a lot by government of India, and that's why I want that each of you should know how you can contribute. So I'll just I can you let me know this is just for 4 or 5 minutes, right? Yeah. So for what I'll say that ancient history tells us that we had lot of innovative equipment in our culture. So, be it medicine, sugar, be it metallurgy, the total stuff, uh, be it urban planning. You go to uh, Sindhu Valley Sabhyata, you will see the urban planning of whatever you got from your ancestor, that was so beautiful. And that's why academic institutions are the most important place from where innovation starts. And that's why every time I focus on youth. Now, in present times, read Google. You all know about Google, right? And even Facebook, Times Magazine. Long, long back, if you go 100 years back, Times Magazine. Recently, Google, Facebook, Reddit, Snapchat, all these are created by students, right? Or very young person who were in their early 20s. So that's why potential lies with youngsters. Innovation is something which is for young minds because you are not having more constraint in your mind. Because as we grow in the ladder, we go up in the ladder, we have lot of constraints. Professor, he has some assignment with him. So he cannot think, he'll take some time out of his busy schedule. But you have plenty of opportunity. So take that opportunity and think about this. Now, we have around how many unicorns we have right now? Do you have any idea? So teacher will take their test also. So do you have any idea how many unicorns in India we have? Roughly? एक तो हाँ ठीक है इसका मतलब गूगल काम कर रहा है नेटवर्क क्या आता है इंटरनेट yes you are right so approximately we have that number and do you have idea how many unicorns we have आप फंस गए यूनिकॉर्न तो बता दिया यूनिकॉर्न नहीं बता पाओगे so we have same number of unicorns also or more than that and what is unicorn unicorn are the endeavor startups which are likely to be unicorn very soon. They are known as unicorn. Right? Now, the potential is with the country. Another fact which I want to share that around from one of the data I have captured this thing, maybe it is updated a little bit, but around 60 founders, unicorn founders we have. And the interesting fact, whenever we talk about the founders, we think that mostly they'll be from Bangalore or Hyderabad because these are the cities well known for innovation. But Uttar Pradesh is having much more number of unicorn founders as compared to Karnataka. So why is this? Because the beginning of this state goes after doing his or her study is going to Karnataka because they are getting well ecosystem there. That's the thing. So now what is your responsibility? Not only to think about the idea, but also to think about how to create an ecosystem which will enable you or your coming generation to stay in your land, in your area, and doing a great job. So this is another interesting fact, and that encourages you. And another fact that when we see the data of unicorn founders, we found that most of them are engineers. So you are an engineer or going to be an engineer. So that is also in your favor. And very interesting thing, so there are some numbers, like 7, 8 numbers, when founders are dropouts also. So that is much more encouraging. That means innovation does not require any sort of, every time it does not require a formal degree, but the passion is needed, right? So I would say that you think about all the complete ecosystem. You follow your professors, you request them that you should have some pitch day in your institute, you should have some mentorship with you. And why I'm saying all these things? Because government of India is focusing a lot in the startup and innovation ecosystem. So that's why I think you have potential. You should think about this, all these things, and I'm very sure that you have lot of experts from your research and academic areas also. So you have not that sort of shortage of mentor with you. So I would say that coming time, you can think about all these things, and I'm very open. You can contact me also in case if you feel that. And very surprisingly, one of you has just contacted me 2 hours back. I don't know how come he got to know. I don't know him, but he got to know that I'm coming. He sent me message on LinkedIn that he wants my number. So that is also something very encouraging. I wish you all a very great and successful career in your future, but be very clear that you have to make your own future. And the time has come when you can do this thing with your capabilities. With all these words, I wish all the success to this conference also, which is very well planned. And I'm very sure that not only you will learn, but I will also learn from this conference during these days. So my best wishes to everyone. Thank you very much.
Thank you so much, sir, for your insightful words. Now, we request Professor Samsher, sir, to kindly take the podium and share his valuable insights with us. Can we please have a huge round of applause?
First of all, of today's function, Dr. Vipin Shukla, Scientist G, Department of Science and Technology. My friend, Dr. Rajiv Kumar Upadhyay, Director of Genetics. My colleague in the university, Professor Omkar Singh, former Vice Chancellor of Uttarakhand University and Madan Mohan Malviya University of Technology. The head of the department and head of the School of Engineering, Dr. Vinay Pratap, the commander of this conference, Dr. Nishant, Dr. Smir, and Dr. Rao, Dean of the University, faculty members, and other departments, researchers, industry experts, esteemed guests, and my dear students. Good morning to all of you. It is a matter of my great pride and privilege to be here in this inaugural session of this peace conference on advancement in materials, machining, and artificial intelligence applications. I extend my warmest welcome to all the participants who have gathered here from across the country and abroad to deliberate on one of the most transformative domains of modern science and technology. Dear friends, we are living in the era where materials are no longer passive elements but active enablers of technological progress. From aerospace alloys to bio-based polymers, from smart composites to nanostructured materials, innovation in material science is shaping industries and redefining possibilities. Globally, manufacturing accounts for significant share of resource consumption and energy use as well as countries' GDP. At the same time, the demand for advanced materials, lightweight, durable, and sustainable, is increasing rapidly. New materials such as recycled steels, bioplastics, and bamboo-based composites are gaining prominence as industries move toward environmentally responsible production systems. Dear friends, machining remains the backbone of manufacturing, whether it is a precision turning, milling, or advanced CNC operations. Machining process determine the quality, efficiency, and cost of production. However, the traditional machining often leads to high energy consumption, tool wear and material wastage, inefficiencies in the process of optimization. Advanced machining techniques integrated with intelligent system are transforming this scenario. The focus has shifted from material removal to material efficiency, where precision and sustainability go hand in hand. Today's sustainability is not a choice, it is a responsibility. The future of manufacturing lies in the concept of circular economy, where materials are reused and recycled, waste is minimized, products are designed for longer life cycles. AI plays a crucial role here by identifying reusable components, enabling remanufacturing and refurbishment, optimizing resource utilization. Industries adopting AI-driven life cycle management have already shown significant improvement, including reduced inventory and enhanced product availability. Dear friends, artificial intelligence has emerged as a game changer in the material engineering and machine processes also. It enables machines not only to operate but to learn, adopt, and optimize. AI applications in machining tools includes predictive maintenance of tools, real-time process optimization, intelligent material selection, and defect detections and quality control. Research shows that AI integration can significantly improve machining efficiency, product quality, and sustainability by optimizing processes and reducing errors in the process. Moreover, AI-driven systems such as digital twins and predictive analytics are enabling industries to simulate entire production processes before actual manufacturing, thus reducing waste and enhancing productivity. Dear friends, let me share some important insights. Manufacturing contributes nearly 40% of global material waste, highlighting the urgent need of optimization and efficiency. AI-enabled sustainable manufacturing system can achieve approximately 20% reduction in the energy consumption, 30% reduction in the waste generation, and 35% reduction in the carbon footprint. Advanced AI-driven composite manufacturing can reduce production cycle time by 30%, improving both efficiency and sustainability. These figures clearly demonstrate that the convergence of material science, machining, and AI is not just innovative, it is essential. Dear friends, looking ahead, we see several exciting developments. Smart materials with self-healing and adaptive properties, additive manufacturing using sustainable materials, bio-inspired and biodegradable materials, green AI, focusing on reducing computational energy consumption, integrating of IoT, AI, and robotics for fully autonomous manufacturing. These advancements will not only improve efficiency but also align industrial growth with environmental sustainability. Dear participants, such conferences play a vital role in bridging the gap between academia and industry. Universities must not only generate knowledge but also translate research into real world applications for the benefit of the last person of the group. Therefore, I urge researchers to focus on impact driven innovation, students to develop interdisciplinary skills, industry partners to invest in sustainable technologies. Collaboration is the key to solving complex global challenges which are multidisciplinary in nature. Dear students and young scholars, you are the architect of the future. Technologies we develop today will define the world tomorrow. Therefore, focus on innovation with purpose, ethical and sustainable practices, continuous learning and adaptability. Remember, true success lies not only in technological advancement, but in its contribution to society and humanity. Dear friends, in conclusion, this conference is not just an academic gathering. It is a platform to shape the future of manufacturing. The integration of advanced materials, intelligent manufacturing, machining, and artificial intelligence form the key to sustainable, efficient, and prosperous work. I am confident that the deliberations over the next 2 days will lead to meaningful insight, collaborations, and innovation. With these words, I wish the international conference a great grand success. Thank you. Jai Hind.
Thank you so much, sir, for the kind words. I now request Dr. Rohit Kumar, sir, coordinator ICAMMAIA 2026, to extend his gratitude by delivering a vote of thanks. Can I please have a huge round of applause?
Very good morning to everyone. Uh, I would like I would like to thank our honorable BC sir to kindly that the time he has shared with us. I would also like to thank our guest of honor, Dr. Bipin Chandra Shukla sir, for sharing his time with us. I would also like to thank our Professor Rajiv Kumar Upadhyay sir for the time that he has shared with us. I would also like to thank all the organizing committee teams and all the volunteers here who have worked tirelessly to make this conference a grand success. Furthermore, I would also like to thank all the keynote speakers for the thoughts that they'll share with us, and I truly hope that their words will make a clear roadmap for researchers to take up the area of manufacturing and machining and also to integrate artificial intelligence with these applications. A conference A conference is nothing with the presenters that they are presented. Therefore, I would also like to thank all the participants of this conference who have joined us and they have shared their papers with us. So, therefore, I would also like to thank them for sharing their ideas with us. As we discuss, I would also like to thank all the student volunteers that have been associated with the organizing team and they have worked tirelessly for this conference. Therefore, I thank you everyone present in this auditorium and I wish that this conference will truly ensure that the area of manufacturing, machining, and integration of artificial intelligence with all these applications will motivate researchers and students present here to take up this kind of area. Thank you, everyone.
Thank you so much, sir. With this, we conclude the inaugural session of ICAMMAIA 2026. Your honor president to follow the high theme. Thank you, everyone. Around that Q session will proceed after working.
keynote lecture, we have Dr. Vipin Shukla sir, Plus. Dr. Vipin Shukla sir, is ING and Tech, the Department of Scientific and Industrial Research, Ministry of Science and Technology, Government of India. A mechanical engineer by background, he earned his master's in design engineering and PhD in advanced manufacturing from IIT Delhi. With 29 years of experience, Doctor has held influential roles, including serving as Senate member at IIT Delhi Federation 2023 to 2025. Now, I would like to invite her to the stage to share his valuable insight with us. Okay, so very good morning once again. Now, hello. Yeah, that's right. Very good morning, everyone, once again, and here I will talk something which may not be academic or research. But as I earlier said, that I'll focus on that what nation wants from you and what you can contribute to the nation. So that is what I would like to discuss here. Next. So first I'll give you a brief about my department, that is Department of Scientific and Industrial Research, which is under Ministry of Science and Technology, Government of India. And we have two other departments, DST, Department of Science and Technology, and Department of Biotechnology. Now, what I have as DST, it has a mandate to carry out the activities related to indigenous technology promotion, development, utilization, and transfer. So primarily we work towards promotion of industrial R&D. Next. So industrial R&D in the country through various support systems like funding the projects and giving recognition to various entities that are carrying out R&D work, and so that they can also get the benefit of incentives, different incentives, creating an enabling environment for development and utilization of new innovation, enhancing innovation through its resources and channelize benefits to the country. So with that vision is to enable India to emerge as global industrial R&D and innovation hub. So just I'll not talk much about that, but overall, if you see skills, we have number of skills with our department, and we skills also consist two different types of skills. One is funding skills, where you can get funding from R&D projects, and another under skills is flagship program, which basically gives recognition to various R&D institutions, industrial R&D hubs, and different public funded research institutions. And we have some attached offices, organization also. Most of you may be knowing about CSIR. You know CSIR? नहीं आप तो जानते हैं मैं बच्चों से चाहता हूँ थोड़ा इंटरेक्टिव रखूंगा मतलब थोड़ा सा इंटरेक्टिव रखूंगा इसमें डरने की जरूरत नहीं है कि मतलब इवन इफ यू आर रॉन्ग आई अप्रिशिएट तो CSIR 37 lakh across the country है and you know there is one specific CSIR lab which is on mechanical engineering जो जो बता देगा
उसको अराउंड ऑफ अपलॉज होगा। गूगल मत यूज करना। तो ये जानो यू आर मैकेनिकल, मोस्ट ऑफ यू आर फ्रॉम मैकेनिकल इंजीनियरिंग आई गेस, राइट? You should know. And we have public sector enterprise also. We have two public sector enterprise. One is NRDC, which primarily deals with the IP-related technology transfer, and probably 2 days back, one of the experts might have visited from this organization. And another is CL Central Electronics Limited. This is the manufacturing public sector. And we have EPCTC, Asian and Pacific Center for Transfer of Technology, which is a regional office of UNSCAP. Right? Next. 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 So, why my department talks about industrial R&D? Because we know that the major chunk of industry and economics is revolves to around MSMEs. MSMEs क्या होता है? पेज कोई बोल के बता दे फटाफट। Micro, small, medium. So that actually one of the data says that it represents around 90% of the total businesses across the world and creates more than 50% of the employment. And that's why this segment is very important. Formal MSMEs contribute towards 40% of GDP in emerging economies. तो हमारे देश की कितने परसेंटेज जीडीपी का कितना परसेंटेज एमएसएमई कंट्रीब्यूट करता है? कोई आईएएस की तैयारी नहीं कर रहा मतलब देखना 30% के अराउंड है and a big number of employment is also generated. And in emerging market, you can see 7 out of 10 common jobs are generated by MSME. And one of the data also talks about just this is 30%, around 30% of the total GDP. MSME contribute towards this. And if we talk about export, in last 4-5 years, percentage share of exports of MSME related projects is around 45 to 50%. So all these data figures tell you about the importance of MSMEs. And you may say like MSME, so I don't care because I have to join MNC. You can say this thing. I don't care. मेरे को MNC ज्वाइन करना है या आप कह सकते हो कि मैं तो आईएएस बनने जा रहा हूँ, मुझे तो आईएएस बनना है, इंजीनियरिंग सर्विसेज में जाना है। जाओगे कहीं पर आओगे यही, क्योंकि बड़ी कंपनी का वेंडर भी यही होता है, सप्लाई यही करेगा, प्रोडक्ट जो है वो एमएसएमई से ही आएंगे। So you should understand the philosophy of MSMEs and what challenges they are having. If you want to be an IAS officer or if you want to join any government job, ultimately you have to serve for the strata of pyramid, right? Because if you see pyramid, so lower class controls the majority. You have to serve for them only. Next slide. Next, yeah. So challenges, if we talk about MSMEs, challenges are technology upgrades. They don't have that thing. They don't know much about commercialization. What is commercialization? How to get into this business? They don't have access to infrastructure like testing facilities, R&D facilities, scale-up, validation centers. Then they don't have sometimes skills. They have skills, but that is not very updated all the time. Because you know AI is now very important in each and every segment. Now, MSMEs, their employees, they are not well versed with all these type of latest technologies. So, where they lag. And expertise definitely they don't have most of the time. And that's why MSME lacks confidence to adopt technology from RI, research institute or academic. Okay. So MSME से कभी इंटरेक्ट किया है आपने? करना, देखना उनकी प्रॉब्लम्स क्या है, चैलेंजेस क्या है. नेक्स्ट प्लीज. तो ये मैंने आपको मॉर्निंग में एक आइडिया दिया था कि स्टार्टअप भी एक नया कॉन्सेप्ट अब आ चुका है इंडिया में. And people are talking about startup, not only talking, but youngster like you are creating your own startup. But very simply getting an idea, most of the time we think that I can be a successful startup owner, but that's not the problem. So it turns out that IT's this system is ranked at fourth largest producer of unique startups in the world. So that's a matter of pride for everyone because we know that we can also do. See, always try to get your share from the data. Like you can say, "अरे मेरे को क्या करना तो आईटी वाला मैं तो यार एचबीटीआई का एचबीटीयू का हूँ." नहीं, अभी जब रिवर फ्लोज फ्रॉम द हिमालय तो पहले तो ठीक है उत्तराखंड में आता है लेकिन फिर तो जाते जाते बंगाल तक जाता है ना. तो यू ऑल्सो follow that stream. So all these things I discussed in that time. So I'll skip. Next. Next. This is something which I want to throw in front of you. And why I'm talking, see, my presentation will carry a number of technical words which you should know when you are passing out from the education. And that when you will go to places like Delhi, Bangalore, Hyderabad, or outside, these words will make you more confident and your uh, chances of cracking all the interviews will become a little bit easier. So you should know TRL. As one of you know about TRL? TRL. सितारों से आगे जहां और भी है. ठीक है ना? कुछ खुश हो गया बोले वाह भाई वाह. तो अभी इसकी कहाँ और भी है, फेल हो जाओगे. फिर कहोगे यार हमने भी इसको किया था फिर फेल हो गए. तो technically, if you enter anywhere, you want to crack anything, do some sort of preparation. You know, when I was in final year of MTech in IIT Delhi, you know, तो HVTI का बंदा था, हिंदी मीडियम से पढ़ा था, राइट. तो वहां पे बताया गया पहली कंपनी आ रही है एंड दे विल जीडी कराएंगे ग्रुप डिस्कशन. एंड आई वाज वेरी श्योर दैट मैं तो कर ही नहीं पाऊंगा क्योंकि वहां तो सारे अक्रॉस इंडिया बड़े बड़े गवर्नमेंट एजुकेटेड हमारे पेरेंट्स के साथ. बट द थिंग my professor told me that yes, I know it's next to impossible for you to get to because this is the first company going to appear for campus interview and around 150 students will participate in this and hardly they will select 10 out of them. So your chances are very big. So he suggested me that something that you bring a long mirror in front of that, you start practicing all these things. And I did something. I took it seriously. And that's why mentors are very important. I could not purchase long mirror because I was a student. ऐसा कहाँ होता था और लाके भी हॉस्टल में कहाँ रखता तो उसका यही सोल्यूशन था वॉशरूम में जाते थे जब देखते थे दिन में कोई नहीं है थोड़ा सा अंग्रेजी बोल लेते थे ठीक है अभी जब जीडी हुआ तो 10 मिनट की जीडी में आई probably I might have given my thoughts just for 1 minute because बहुत सारे गवर्नमेंट एजुकेटेड मेरे साथ थे and they were very fluent. They spoke a lot actually. And you know when result was out, what happened? Very easy. You can tell that you were selected because स्टोरी सुनाओ तो सिलेक्ट हुआ ही होगा नहीं भाई शाहरुख खान था मैं I was number one in that. And that felt my life, my thinking way. And that was the day when I concluded that there is nothing impossible in life. I spoke only probably 59 milliseconds, but I was number one because whatever I spoke was based on facts, was based on quality, it was not a garbage. And it was not that overconfidence that yes, I can speak well or whatever, I can fight, vocal, I'm not shy, all these. So that's why I'm saying that whenever you go, you do some preparation. Without preparation, you will be paid everywhere, even though you are very intelligent and sharp in that. So TRL is very common buzzword across like society, technical society. You should know. And just for easier way, I will tell you that whatever research you do in your academic institution is up to the lab scale research, which is most of the time is known as TRL 1 to 3. That is technology readiness level. Meaning any technology is ready up to this skill level. And after that, you do some prototyping, you do some validation, you do some pilot scale production. That is from TRL 4 to 6, 7, right? And after that, we say that this is TRL 8, 9 is basically for technology commercialization purpose. And that's why if you understand TRL, then you will be very easily understand why MSMEs and industry are very important to academic and research institutions. Because whatever research you are doing at your premises has no meaning for commercial world. And that's why sometimes it happens even if you think that you have done a great job, people are not accepting it until unless you put that thing in front of market. So that's why there are number of Korean people keep on publishing. You can see, you can go through, you can try to understand, but I'll tell you that TRL you should understand. When TRL primitive and latest prevalent definition and concept is developed by NASA. Nowadays, many other agencies, as per their requirement and suitability, they are also amending TRL concept and making in their ways. Next, please. So, whatever I said, this is value of death. Value of death क्या होता है? अब मैंने कहा भाई से पूछे बोलो वैल्यू ऑफ डेथ तो होता है जब गर्लफ्रेंड नहीं आती तो हम जाके पूछ जाते हैं दैट इज नॉट वैल्यू ऑफ डेथ तो टेक्नोलॉजी में वैल्यू ऑफ डेथ भी उसी तरह का है आप एक रिसर्चर हो आपको एक ड्रीम सवाल है कि मुझको ये टेक्नोलॉजी डेवलप करनी है और आपने कर दिया और वो शुरुआती दौर है अकेडमिया पूरा कर दिया तो अब आपको MSME या इंडस्ट्री पूछ नहीं रही है, मार्केट में जा नहीं रहा, तो आप टेक्नोलॉजी क्या होगा, डेथ हो जाएगी, वो उसकी वैल्यू ऑफ डेथ है। तो वैल्यू ऑफ डेथ से बचने के लिए हमें MSME की बहुत जरूरत होती है, हमें मिल के काम करना होता है। आप कहीं भी जाओगे, कोई भी करियर बनाओगे, आप इंडस्ट्री में भी जाओगे, अल्टीमेटली आपको एकेडमिक रिसर्च इंस्टीट्यूट के पास आना पड़ेगा। अगर आप रिसर्च इंस्टीट्यूशन ज्वाइन करोगे एकेडमिक इंस्टीट्यूट, तो आपको MSME के पास जाना पड़ेगा। तो दोनों ही तरफ एक दूसरे की जरूरत होती है, एंड दैट्स व्हाई वैल्यू ऑफ डेथ can be avoided if you do a better interaction. Next, please. Next. So, I'm just giving you some flavor about all these things, and see, this is kind of okay actually for you. I'm not saying that each and every slide or each and everything you should try to explore. You go for whatever you feel attractive to you, right? Now I'm talking about across the world, three very successful manufacturing models. One is Catapult UK. किसने सुना है Catapult UK के बारे में? नहीं सुना है ना? ये जानो ये सब, ठीक है? ये सब बहुत इंटरेस्टिंग चीज है। यूके के UK has created 9 advanced technology and innovation centers, right? And these are primarily for doing R&D and manufacturing of different products, and provides a unique combination of cutting-edge R&D facility and world-class technical expertise to support UK business innovation. And you know, the interesting fact is, numbers you can see that how successful this model is, right? And here on the bottom you can see where the funding comes from, grant. What grant is from government or from the institutions you get from government. So that is one third, but one third comes from commercial funding. That is from industry. And one third collaborative, means even though a lot of collaborative project with industry. So that is the way to create a pool of fund for their work. So this is one model you should explore. Next, please. This is Fraunhofer. Fraunhofer is Germany. It was conceptualized in Germany, and name says that Fraunhofer. This is for commercialization of technology. क्योंकि मेरे को एक चीज अभी तो नहीं बता पाओगे, लेकिन सर्च करके कभी बताना। जर्मनी में दो बहुत सक्सेसफुल मॉडल है। एक फ्राउनहोफर सोसाइटी है जो नॉर्मली TRL 4 एंड अबव का रिसर्च करती है। एक और सोसाइटी है जो TRL 3 तक का करती है, एंड दैट इज ऑल्सो हाईली रिस्पेक्टेड एजेंसी इन द वर्ल्ड। ठीक है, उसको सर्च कर। तो ये 76 इंस्टीट्यूट है इसका, बड़ा मॉडल है इसका, एंड फ्राउनहोफर की तो कई ब्रांचेस अक्रॉस द वर्ल्ड भी है। इंडिया में बैंगलोर में इसका ऑफिस है। So they also do lot of innovation in manufacturing and commercialization, and 70% they get contract from industry and 30% from government. So what I want to convey that, please do be dependent only on government. There are the successful models across the world, they don't go much for government grant. They know government will always be a government, be it Indian government or UK government or anywhere, because they have social bindings also, social responsibility also of each government. So they will divert this fund time to time based on the situation. So you have to be dependent on industry, and there MSME will be your working partner. Next, please. This is the third model which I want to display. This is manufacturing USA. It has 17 advanced manufacturing institutes across the US. And industry, academia, government partners, they all are jointly doing this initiative. And here also, if you see the last, in 6 years, contributions from industry rose to 72% from 55%. In 6 years, in 6 years time, they enhance this industry grant. So that is what I wanted to convey, that yes, across the world, all the successful models, they are banking on industrial support, industrial funding, not government. But it does not mean that I am saying don't come to me. Still, do come to us. But you make yourself so strong that one day industry will come to you and say that please take my money and do this research or do this technology development. Okay. So these are some numbers which is in front of you just to understand that where we stand at present. So R&D expenditure, if we see in percentage of GDP, we are around 0.64 or 0.69. And you know, Israel has more than 4% of GDP. They are doing R&D expenditure. Just see South Korea, around 3% of GDP, they are doing R&D contribution. So we are lagging behind, but we need to improve upon. But yes, we have some better advancement in terms of if you see scientific and technical math, scientific publication, patent application, all these things in last 4-5 years, we are moving very good. And if you see sector-wise R&D spending, still we are depending on government funding, and industry funding is still 1/3. This is something we have jotted down after doing lot of analysis and try to get a feel of this slide rather than and it's not an academic slide. You will have to feel that what I want to convey. We all talk about US, especially Silicon Valley, right? So why that is very successful? Venture capital powerhouse. Just read all these things. Risk tolerant culture. They are ready to take risks. And we don't bother about all these things. Why we don't bother? Because we have apprehension. We think that if technology is not successful, what loss I am going to make. But we don't think that if we are not going to be successful, what learning we are going to get. So that culture is in Silicon Valley. Startup support, a lot of tech accelerator out there. एक्सीलरेटर क्या होता है? किस ईयर के हो आप लोग ज्यादातर? वो भी नहीं बताओगे, बोले आज नेक्स्ट यार बताओ, मार्ची में हो गए मिड ईयर कहते हैं, मैं तो सब कह रहा हूँ 6 ईयर में हो, मैं तो घबरा गया थी अभी तक 6 ईयर कुछ है। तो मारुति में है ना, अब जाओगे तो वहां पूछेगा ये सब कि टीआर कौन से टीआर है, फिर कहोगे अभी टीआर का तो एक्टिविटी का भी तो नाम रखना है ना वहाँ पे। वहां जाके इंग्लिश से कुछ कुछ चीजें बोल देना, बहुत अच्छा इंप्रेशन बनेगा। तब फाइनल ईयर वालों से बोल रहा हूँ, जहां जहां जाओगे ना, ये 2-4 स्लाइड जो है ना, इसको याद कर लेना। वह ये बोला edge over risk taking culture. They have venture capital, lot of venture capital. They work on accelerator. तो क्या बोलोगे, वो ऐसे समझ जाएगा बंदा सब जानता है, ठीक है। बट केवल इसको देखने के बाद यू गो थ्रू ऑल दोस थिंग्स। So this is the point with US and especially Silicon Valley. सिलिकन वैली में फोर फादर्स में कौन आता है, एक नाम बताओ जो इंडियन है। अरे तुम्हारा कानपुर से है यार, यू शुड नो। मैंने तो फेसबुक में उसको जोड़ा हुआ। कमल रेखी, IIT कानपुर, IIT बॉम्बे, ही वाज टू कानपुर, बिलोंगिंग टू कानपुर। सिलिकन वैली की शुरुआत से ही वाज इन्वॉल्व। सो व्हाट आई वांट टू कन्वे दैट इज, कहीं भी चाहे सिलिकन वैली में अगर सक्सेसफुल है तो उसमें भी हमारा रोल है। नासा भी अगर सक्सेसफुल है उसमें भी हम हैं, राइट। तो जिनको केवल अपने इस पर थोड़ा सा ब्रशअप करना है ना। और मैं तो PhD कर रहा था, तो मेरा थीसिस जो मेरा टॉपिक था उसमें एक इलेक्ट्रोमैग्नेटिक ब्रश बन। तो वो ब्रश करते करते थोड़ा सा उसमें डस्ट पार्टिकल या जो एरोड होता था वो भी आ जाता। सो ब्रश को फिर से हमें रिफ्रेशन करना पड़ता। तो जब इतनी छोटी सी चीज को रिफ्रेश करना पड़ता है तो हमें अपनी कैपेबिलिटीज को भी बार बार थोड़ा सा माइंड को रिफ्रेश करके याद करना होगा कि यस वी कैन डू दिस। नाउ जर्मनी, एवरीवन नोज दैट इनोवेशन ड्रिवन मैन्युफैक्चरिंग। जर्मनी का नाम लेते ही क्या याद आता है दिमाग में, बड़ी बड़ी मशीनें याद आती हैं। वो मैन्युफैक्चरिंग का हब है। इंडस्ट्री, ऑटो इंडस्ट्री, ये सब बड़े बड़े और उनका एज तो और वो स्मार्ट इसलिए बिकॉज इसे अब तो टेक्नोलॉजी इंडस्ट्री 4.0 पे भी वो चल चुके हैं। गवर्नमेंट सपोर्ट है उनके पास, वोकेशनल ट्रेनिंग, उनका एक्चुअली ट्रेनिंग और स्किलिंग का बहुत स्ट्रॉन्ग नेटवर्क है। जिन्होंने आप PhD भी तभी कराते हैं जब मिनिमम 8 साल की आपकी इंडस्ट्री एक्सपीरियंस हो जाता है। तो दे नो कि इंडस्ट्री को बढ़ाना है तो इंडस्ट्री का अंडरस्टैंडिंग होना चाहिए। और दोनों में मैंने इम्पैक्ट डाले लास्ट में, जैसे सिलिकन वैली का इम्पैक्ट अगर आप देखिए सारी कल्चर का, तो गूगल, एप्पल, मेटा, टेस्ला है। इधर तरीके सीमेंस, बॉश, BMW, ये सिंगापुर की जब बात करते हैं तो नॉर्मली डिजिटल ट्रांसफॉर्मेशन एंड पॉलिसी एफिशिएंसी की बात होती है। प्राइमरी गवर्नमेंट में भी एफिशिएंसी की बात होती है। दे आर सपोज टू बी वन ऑफ द बेस्ट इन गवर्नमेंट एफिशिएंट कल्चर ऑल्सो। और उसके लिए दे हैव फोकस नॉट ऑन AI, बिग डेटा, IoT, और मेनली ये गवर्नमेंट से जैसे हम भी कर रहे हैं काफी। पर हमारा जैसे इंडिया का, हम डिजिटल टेक्नोलॉजी का बहुत यूज फाइनेंशियल टेक में, फिनटेक में बहुत हमने किया है। एंड दैट्स व्हाई वी नो दैट सो मेनी, इवन आवर वेजिटेबल वेंडर आल्सो हैज a UPI and he has minimal understanding of all these things. And that's why Singapore ranked number 1 in ease of doing business. इसराइल की जब बात करते हैं, छोटा सा देश है, बहुत कम पॉपुलेशन है, तो गवर्नमेंट R&D और स्टार्टअप का उनका काफी कल्चर है। गवर्नमेंट बहुत सपोर्ट करती है मिलिट्री ड्रिवन टेक्नोलॉजी इनोवेशन। दिस इज वेरी वेरी इंटरेस्टिंग। आप थोड़ा सर्च करना, पहले तो दुनिया के 70% से ज्यादा जो इनोवेशन इजाद होते हैं, टेक्नोलॉजी यूज करते हैं, वो सब इसराइल के लोग कहीं ना कहीं से जुड़े हुए हैं। और यू नो दिस मिलिट्री ड्रिवन टेक्नोलॉजी का क्या मतलब है? पॉपुलेशन बहुत छोटी है और लड़ाई झगड़े होते रहते हैं, तो मिलिट्री में सबको जाना होता है। लेकिन जब मिलिट्री छोड़ता है तो वो एक स्टार्टअप क्रिएट करता है। उसको पता है कि हमें मिलिट्री को क्या चाहिए, वो स्टार्टअप क्रिएट करके, और इतने बड़े बड़े स्टार्टअप में आज पूरी दुनिया को सप्लाई कर रहे हैं। और आप जो वहाँ स्टार्टअप का ओनर होगा, वो शायद सेना का जवान था, रिटायर्ड जवान, सिर्फ एक जवान होता था, लेकिन ओवर द 10 years time or 12 years, whatever he served for the army there, he learned a lot, and then he made his own company, and now that company is almost that sort of culture they are living with. So all this, you can see impact, and you can see all these companies. You can well understand that, and that's why I'm saying when I talk in the morning that you have one encouraging fact from the data that dropouts are also founders of unicorn. So the same way, simply a Jawan of military is having worked for a company with him. So that is what we should learn from this successful culture of this country. Next, please. So conclusion, I concluded that this is not conclusion of the slide of my presentation. So अभी थोड़ा सा और इंतजार करें. तो ये कंक्लूजन है कि हमको हर कंट्री का बेस्ट से क्या सीखना चाहिए. ठीक है, अब इसको मैं आगे बढ़ जाता हूँ. नेक्स्ट प्लीज. अब सोचोगे कि मैं तो यार थोड़ा एक्सप्लेन कर देते तो याद करता है. तो जो स्मार्ट है उसने फोटो खींच लेनी चाहिए कैमरे से, खींची नहीं. टेक्नोलॉजी को यूज करो. नहीं ये खींच रहे बच्चों को कह रहा हूँ, ये खींच लेते फोटो. बहुत मेहनत करोगे ये सब करना, लेकिन अच्छा मेहनत करोगे तो सीखोगे भी बहुत. अभी ये मेरा आई जस्ट not take much time just to show that how government is my department is focusing on doing Atmanirbhar Bharat and how we are making manufacturing, promoting manufacturing. Next. So this is one of our schemes. Across the country we have 18 centers. And I'll advise you that only one center you go to of IIT Kharagpur and CRTDH. CRTDH. You see, and just see how they have democratized the technology to reaching to Sundarban also, where no one can reach. And during COVID period when everybody was in big trouble because we were not having RT-PCR facility or it was taking too much time. They created their own COVID app. And even on a bicycle, they went to Sundarban. And in half an hour, results also came. And that's why they have got US license and US has taken their technology. US company. Such type of efforts are not only financially beneficial to them, but also social impact is very high. Reaching to unreached people, unreached area is something which technology can play a very good role in that. So these are some of the examples through different our CRT news. Next, please. Some of the these are IIT Kharagpur products under CRT. And they see why I'm saying this. See, even they whatever they develop, they mention TIL also, TIL5, TIL. So learn all these things. That how can you use all these things? Yeah, next. Okay, this is COVID related work. Next. This is another scheme which I will request our faculty member that if they feel they can apply for getting grant. Not going into detail, but we have different type of sub scheme under this scheme. One is studies. We give support for study. We give support for events. We give support for women-centric scheme. This is interesting PDMPW where we say that we give grant to those projects where you can uplift the livelihood of women, especially women in community, right? Fishermen community, women are doing a lot, but how technology can intervene in making their life better. And for that purpose, this is very interesting scheme. Next. So all these come of the how we work, all these things like stakeholder engagement, technology assessment, SCI problem statement, dynamic platform we create, AIML model. So government is also doing lot of things which are AI linked. Next, next. All these things are success stories of our next. Next. This is another very interesting scheme where an individual can also, this is one of the only schemes of the government where an individual can also get funding. This is known as PRISM. And this is basically promotion of this individual startups and MSMEs for promoting innovation among them. So I would suggest that even any of you have any idea and you want some very small funding, 2 lakh, 3 lakh, 4 lakh, you can think for this and you can create your own prototype. Next, please. These are successful projects. And you see just Rickshawala also got it. He got this funding. So very democratized scheme. Ground level people are also involved. Next, uh, okay. So this is recognition. Here I will not go into detail. I will only request you, sir, if just ensure from your people or authorities whether you have recognition of this because all PFRI they get this recognition that will give lot of incentives and most of the time when you apply for funding from any of the government agencies, if you have that recognition, it adds value to your effort. Next, this is I skip. This is about industry, how we recognize industry for doing R&D. Next, yeah, next, just wait. And this is the incentive which normally industry gets on doing R&D work. So whatever amount they have utilized for doing R&D is exempted from income tax calculation. Next thing. So this is something once again what government wants from you that how we can work together. So this is again just of all the slides which I made, starting from where we stand in R&D expenditure, what others are doing, and then what is the profit for us for future. Next thing. And you may think why I'm skipping so fast on these things because I know everything is not useful for everyone. So ever feels that yes, this is something interesting, he or she can write to me on official email or LinkedIn. Next thing. Thank you very much. Thank you.
Thank you so much, sir, for your enlightening words and valuable time. We are very grateful to have you here. May I now request the Head of Department Mechanical and Dean School of Engineering to kindly felicitate our speaker for his enlightening expert lecture. If anyone has any questions with sir, they can ask. If anyone has any kinds of queries with sir, that they can ask. All right.
Starting the next current moment. I would like to invite my fellow speaker to introduce our esteemed keynote professor.
Thank you, Devanshi. For the next keynote session, we have among us Professor Rajiv Kumar Upadhyay, sir, Director, Kamla Nehru Institute of Technology, KNIT Sultan. He has been serving in this esteemed institution since September 2023. Prior to this, he held the position of Director at Hindustan College of Science and Technology, Mathura, from 2013 to 2023, where he contributed significantly to academic excellence and institutional development. He is also an accomplished author who has published over 50 research papers in reputed national and international journals. Professor Upadhyay has been honored with several prestigious awards, which includes the Outstanding Engineering Services Award and Excellence in Leadership Award, in recognition of his remarkable contributions in engineering education in the country. He is also a fellow of the Institution of Engineering Technology, United Kingdom, and the Institution of Engineers, India, and contributes to actively contribute to academia through editorial responsibilities and participation in various professional and academic bodies. With great honor and privilege, I would now like to invite Professor Rajiv Kumar Upadhyay sir to the stage to deliver his expert lecture. Thank you very much. Mechanical engineering department and their students. First of all, I would like to thanks to organizer for inviting me to deliver a keynote address. I would deliver a lecture on Industry 4.0. Number one student I hope that you are from mechanical engineering. So we are in an era of additive manufacturing. And suddenly, from subtractive to additive, we are against. The traditional method which we are using or which we were used, these all methods were subtractive manufacturing. Now we are in a era of additive manufacturing. Additive manufacturing of 3D printing has the full potential to be a disruptive technology. Any student who is sitting here, you have any idea about disruptive technology? What is disruptive technology? If you have, please raise your hand. Any one of you? What is meaning of disruptive technology? If you have any student have any idea about disruptive technology, please raise your hand. Yes. जोर से बोलिए No. First to answer, but not today. Any other idea about disruptive technology? You have any idea about disruptive technology? Now, we will discuss about disruptive technology also. But if you want to know about disruptive technology, you can remember one thing. Disruptive technology is a technology which has the potential 100 times more for which it was intended. Disruptive technology is a technology which has the potential 100 times more application for which it was intended. This technology is known as the disruptive technology. So the 3D printing or additive manufacturing has the full potential to be disruptive technology in future. So what is Industry 4.0? Because Industry 4.0 is an amalgamation of multidisciplinary things in mechanical and other
other discipline of electronics, computer science. So next, please. So we know that these are the fourth revolution of industrial revolution. First was based on the water power, steam power. Second was mass production, assembly line, electricity. Third was computer and automation. And fourth was cyber physical system. The cyber physical system is our Industry 4.0. These are the related to Industry 4.0. You can call the Industry 4.0. If you want to learn the Industry 4.0, you should remember one keyword, that is the cyber physical system. Next, please. Next. So now the first this Indian revolution took place, and this is the 18th century. That is the mechanical move. And second one was these are the period for second, third, and the fourth industrial revolution. That is the cyber physical system. So these are the first, second, third, and fourth. Next. So now we are in the era of smart manufacturing. The traditional manufacturing is the application of 5M. As you know that man, machine, material, method, and money. These are the to convert the raw material into finished good with the application of man, machine, material, method, and money. This is the traditional manufacturing system. But now we are moving from the traditional to the modern manufacturing system. So what is the smart manufacturing? What is the smart product, and how can we use the artificial intelligence in case of the smart manufacturing and smart product? Next, please. So now, next. So what does Industry 4.0 mean to us? So now Industry 4.0 is the more efficient, more individual solutions and faster. Next. So now these are the smart products. This is the one diagram by which you can learn about what are the input and what are the output for the smart product. So these are the material data, process data, material status data, machine status data, production planning data, and energy consumption. In the right hand side, ready availability of material product, good quality of the product, low production cost, and higher through output. How they are connected to each other? Which one is connected to which one? Now, by this diagram, you can learn what is the smart product. Next. So, next. So, these are the design principles of Industry 4.0. There are the 6 design principles of Industry 4.0. Next. This is the detail of design principle of Industry 4.0. We will not go in detail. So you can see these are the 6 basic design principles for Industry 4.0. Next. This is the cyber physical machine tool or digital twinning. So these are the basic principles or basic tool for Industry 4.0. Next. So this is agile pre-machining process. What is agility? Agility is related to flexibility in the system. The flexible system, the agile system, what is agile manufacturing? I think all of you are familiar about the agile manufacturing. What is agility, agile manufacturing? Control of machines becomes a service condition, monitoring easily done, machine optimization, on-demand manufacturing. Next. These are the basic components, these are the basic elements of Industry 4.0. If you want to learn Industry 4.0, you have a clear idea about these all things, that is the augmented reality, big data analytics, autonomous robots, simulation, horizontal and vertical integration, industrial internet of things, 3D printing, cyber security, AI and machine learning, and advanced vision system. These the Industry 4.0 is the evolution of these elements. So if you want to define, if you want to learn about industry 4.0, you must have some basic idea about these all elements. After getting the basic idea, you can explain the industry 4.0 in a various domain. Next. In the industry 4.0, there is a one additive manufacturing. This The additional manufacturing is known as the subtractive manufacturing. Or this is the additive manufacturing. Additive manufacturing is inspired by nature. The basic principle or the basic event of the industrial this additive manufacturing is from circular to process. If you want to learn about additive manufacturing, if you want to note one keyword of additive manufacturing, you can remember only this word, inspired by nature, and the basic principle is from circular to process. Next one is, so this is the comparison between the conventional manufacturing process and additive manufacturing process. What is the difference in material? What is the difference in machining? What is the difference in product? And what is the status of scrap or waste? So this is a one comparison of this conventional manufacturing system and the additive manufacturing system. So conventional manufacturing system is also known as the subtractive, and this additive manufacturing. So now by word itself, it is implied that what is meant about the subtractive means from gross to what is meant about the additive from circular to gross. So this is the one line definition, one line differentiation between the subtractive and additive manufacturing. This is the in first case it is gross to circular. In second case it is circular to gross. Next. This is the 3D printing market in India. Now, this 3D printing is being used in each and every domain of in India also. But at present time, the application of industry for this the 3D printing is limited due to the capital investment, initial investment. But still, in India, the 3D printing is being used in each and every domain of the life. In case of the automobile industry, in case of the civil and construction, in case of the medical industry, and all. Next. Now, this is the one example. This type of solution can only be given by the additive manufacturing. Testing is not possible by any method by the subtractive manufacturing. This is the one example of additive manufacturing. Up to what extent the additive manufacturing can be used, how the manufacturing can be customized, how the manufacturing can be used for complex problems, how the difficult component can be manufactured. These are the application of additive manufacturing. Next. Now the 3D printing will give endless freedom in India. Such type of products are being used for 3D printing in India. Next. In automobile industry, the ample application of 3D printing is being used. The industry are being used for 3D printing in automobile industry also. Next. In civil construction, in our this country also, there are some buildings which are available which were constructed by 3D printing. And in the China, you will find the n number of buildings which were constructed by the 3D printing. Total construction of building was done by the 3D printing. The less time, the quality, and all things, it is only possible by the 3D printing. Next. With the medical industry, our medical industry has an ample this opportunity or ample applications of the 3D printing. Within a 5 year or 10 year, you will find a significant change in the cost. The cost will be lower for medical components by using the 3D printing and customize this medical test can only be conducted by the 3D printing. It will be a disruptive technology and the time will come soon in India. Each and every doctor has its own 3D printer. And if you will meet the doctor will design, the doctor will take the part as per your requirement. The part will not be the common. Now there is a one law of the size of board is like this. If the customized product can only be possible by the 3D printing, the time will come soon in India after 5 or 10 years. If you will meet a doctor, the doctor will have a 3D printing in his office. He will take your requirement, and according to your requirement, the customer part on medical will be produced by that 3D printing. Next. Here, the conclusion of this additive manufacturing will obviously take place last year of manufacturing process. It's a breakthrough in manufacturing technology.
It's still a lot of research and development being conducted to improve speed, quality, cost, and size of part. And what be the significant change? What would be the significant change in the 3D printing? When the 3D printing would be in practice, that there are the two costs which would be minimized or maybe zero or minimized. These costs are number first is the inventory carrying cost. The inventory carrying cost would be zero in case of the 3D printing. Or second one, as far as the design part is concerned, so the cost which are being incurred of the design, their cost could also be minimized after application of the 3D printing. Next. So this is the other component of Industry 4.0. This is the augmented reality with virtual reality and mixed reality. You should have some fair idea what is virtual reality, what is augmented reality, and what is mixed reality. Next. This is augmented reality. Next. We have what next? The second component or second element of this Industry 4.0 is the data analytics. It is the what is database, data warehouse, ERP, CRM, audio, video. So now this is the one this concept of Industry 4.0, and this concept could be used even in the mechanical engineering industries also. Next. So next. 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 Now, this is the concept of blockchain. You have a this a fair idea about the blockchain because it's also a part of Industry 4.0. What is cryptocurrency, what is cryptography, what is pattern recognition? These are the first steps. So, by which the mechanical engineering students should also know these things because it will give you a lot of understanding about Industry 4.0. Next. This is the industrial internet of things. So factory of future, what would be the factory of future? You will find tabletop machines in mechanical industries. Where the time of lathe machine, drilling machine, shaper planer, the time has almost gone. But with these machines, you can take a basic idea, basic info. When you will enter the industry, you will never find even this such type of machine. You will interact with a tabletop machine. So the future factory would be like this. If you will prepare yourself as per the requirement of future factory, then you will find you will live a quality life. If you will keep away from yourself about these development, these advancement, then it may create a problem for the job for you. So I would like to request to all my dear student, what is Industry 4.0? What are the elements of Industry 4.0? You should have at least a fair idea by which you can explain only the meaning and basic concept of the Industry 4.0. Next. So this is the artificial intelligence, machine learning, and deep learning. As a mechanical engineer, you should have a basic idea, clear idea about what is because the topic is related to the artificial intelligence. But in case of the artificial intelligence, you should keep one point in your mind that human intelligence is the superior intelligence. No intelligence in this universe can overcome the human intelligence. So by keeping this point in your mind, that human intelligence is the superior intelligence, but how the artificial intelligence can be used, to what extent the artificial intelligence can be used, but artificial intelligence can't be a substitute of the human intelligence. Human intelligence is a superior intelligence. Next. Next. This is about speech recognition, machine learning. Next. This is the journey of artificial intelligence 1956, 69, 97, 2002, 2018, and what was the development of 2018 to 2005. You should know the journey of artificial intelligence. Next. This is the autonomous robotics because robotics is your one subject of mechanical engineering. So how robot can be trained, how robot can be used with the help of artificial intelligence. You should know this thing. Next. 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 This Industry 4.0 will get the aspect of economy, business, national and global, society, and individual. Next. This is the demand slide for our students. If you want to develop for Industry 4.0 to yourself, these are the quality. You should know what are these qualities and how would you inculcate these qualities in your personality. If you are able to develop this quality in your personality, then if you will enter in the environment of Industry 4.0, you will find a suitable environment for you. These are the quality complex problem solving. How can you inculcate a complex problem solving habit in your personality? Second one is the coordinating with others, people management, ethical thinking, negotiation, quality control, service orientation, judgmental decision making, active learning, and creativity. So, for the creative thinking, I would like to narrate one example to all my dear students. Creative thinking. What is the creative thinking? If you want to learn about creative thinking, so I would like to narrate one small story by which you can better understand what is the creative thinking. In the हेलो हाँ स्टूडेंट्स आप सभी को मैं एक हिंदी में एक स्टोरी बताना चाहता हूँ जिससे आपको क्रिएटिव थिंकिंग का मतलब समझ में आ जाए अच्छी तरह से तो क्रिएटिव थिंकिंग के लिए मैं आपको ये बताना चाहता हूँ आप लोग ध्यान से सुनिए जरा यूएस में जब आइसक्रीम आप लोग खाते हैं हम लोग आइसक्रीम खाते हैं जो आइसक्रीम का होता है तो यूएस में जब आइसक्रीम का आविष्कार हुआ जब आइसक्रीम को बनाया गया तो उस टाइम ये वाले का प्रिंटेड जिसका हम आइसक्रीम खाते हैं उस टाइम क्या होता था एल्युमिनियम का प्लेट में रख के आइसक्रीम मिलता तो जो एल्युमिनियम के प्लेट में रख के जब आइसक्रीम मिलता था तो वहां लोग क्या करते थे उस आइसक्रीम को खा के प्लेट को वही फेंक देते थे तो वो जो सिटी का जो सीईओ था जो उसका बॉस था जहाँ पे आइसक्रीम का ये इन्वेंशन हुआ तो उसने जितने भी आइसक्रीम मैन्युफैक्चरर थे उनका एक मीटिंग कॉल किया और उसने कहा कि फ्रॉम टुमारो आई वुड बैन योर आइसक्रीम फैक्ट्री बिकॉज हमारे यहाँ गंदगी स्वीकार नहीं है तो जो प्लेट होता है उस प्लेट को आप जैसा कस्टमर फेंक देता है वो उसमें बहुत गंदगी होती है there were the 400 people of ice cream manufacturer were sitting in a hall like this. CEO was sitting on the dice. तो उसने कहा लो अब तो उन्होंने डिसाइड किया था we have invested so many amount of money, huge amount of money, give us some time, 2 महीने का टाइम दीजिए 4 महीने का टाइम दीजिए तो उसने कहा कि नहीं आपको कोई टाइम नहीं मिलेगा आपको कल से मैं आपका ये आइसक्रीम बंद करूंगा आर्ग्यूमेंट करने के बाद वो 399 जो लोग थे वो बाहर चले गए बॉय जो एक उसका जो था उसके माइंड में कुछ आया तो उसने कुछ आर्गुमेंट किया तो उस जो सीईओ था उसके मुंह से ये निकला कि मैं एक ही कंडीशन पे आपको दे सकता हूँ परमिशन कि आप ऐसा कुछ कर दीजिए कि जो ये प्लेट है ये प्लेट को आइसक्रीम खाने के बाद इसे दिखाए ये जो वर्ड उसके जो लड़के ने सुने तो उसको ये लगा कि कुछ न कुछ तो है इसलिए गुस्से में ये वाली बात बोली है बट देयर मेरी सब चांस क्या ऐसा हो सकता है कि जो आइसक्रीम खाने के बाद जिसमें आइसक्रीम खाई जाए उसको भी खाया जा सकता है तो जो आइसक्रीम जो आप कप आज खाते हैं दैट इज द आउटकम ऑफ क्रिएटिव थिंकिंग ऑफ दैट अगर वो भी 399 की तरह 400 के साथ आप बाहर निकल जाता तो आज की आइसक्रीम आप एल्यूमिनियम की प्लेट में खा रहे हो तो इनोवेशन के लिए इनपुट क्या है इंग्रेडिएंट क्या है व्हाट इज द इंग्रेडिएंट फॉर innovation the ingredient of innovation is the creative thinking if you will develop the creative thinking in your mind then you can change your mindset your thought process will change first you should inculcate the habit which can develop the creative thinking in your thought process thinking from different from others. 1,000 people are sitting and 999 thinking in one direction. How can you think that thing in a different way and with some physical solution? आप ऐसे कोई thought करते हैं जिससे कोई solution ही नहीं होगा, it will not work for you. So these are some qualities by which you can develop yourself for Industry 4.0. As I told you previously, the disruptive technology, the 3D printing has a full potential to be a disruptive technology. After 10 years, you will find 3D printer everywhere. Every doctor, every structure. So you will prepare yourself for 3D printing and additive manufacturing. You should inculcate these qualities in your personality. These are the complex problem solving. If critical thinking, creativity, people management, coordinating with others, emotional intelligence, judgment and decision making, service orientation, negotiation, and cooperative flexibility. What is emotional intelligence? Emotional intelligence is this. There are the three ways of learning to anything. If you want to learn anything in your life, there are the only three ways which are available. First one is you can learn the thing from the human. Second thing, you can learn the things from the machine. Or third one, you can learn the things from the animal. There are the three ways only. If you want to learn any language, any software, anything you want to learn in your life, there are the three ways you can learn from human, you can learn from machine, you can learn from environment. So learn from the human is known as this is the emotional intelligence. If you want to learn something from me, so you should know how should you behave, how should you act, how should you interact. If you know these things, then you can learn the things from the other. That time has gone, okay, you can learn only from your teachers. No, that time has gone. You can learn from your friends. This is known as the peer-to-peer learning. This is known as the horizontal learning. Horizontal learning is the fastest mode of learning. Second one is the vertical learning. Vertical learning is that your teacher is in class and you are sitting on the bench. This is the vertical learning. Horizontal learning is this: you are in a residing in a hostel, and three boys are in that hostel. And if you will learn some particular concept from your roommate, hostel mate, it will give you a hostel learning. Then this type of learning is known as peer-to-peer learning or horizontal learning. So now this is the time by which you can interact, you can conduct brainstorming session to your friends and about the cutting edge technologies, and by which if you will inculcate these 10 qualities in your personality, it will give you a new exposure about the industry 4.0. Next. These are the benefits of industry 4.0: safety, quality, cost and delivery, product development and management. These are the benefits of industry 4.0. Next. 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 There are some limitations of industry 4.0 in our country. There are some limitations, so we are not able to implement, or even our government has taken a lot of initiative. How can we go ahead with 3D printing? How can we implement the concept of 3D printing? But these are some limitations by which the total implementation, 100% implementation is not possible. But time will come soon, and you will find everywhere 3D printing and industry 4.0. Next. 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 I hear, I forget. I see, I जब आप करेंगे उसको, आप स्किल डेवलपमेंट करेंगे, तो यू विल understand and you will never forget this concept in your life. So I think thank you very much. Thank you very much. If you have any question, any question in your mind, I think you are not in a this position to ask a question because the previous session and this session in university the very long time. But still, if you want to ask any question, raise your hand. I will try to reply your questions. Otherwise, thank you very much for organizers for inviting me in this international conference. And I hope that the students and the participants will receive a very good recipe for advancement in materials, machining, and artificial intelligence. Thank you very much.
Thank you, sir, for your enriching and insightful address and your valuable time given here. Now, may I now request Dr. Nishant Kumar sir, the convener of this conference, to felicitate the speaker for his enlightening expert lecture.
Now the following invite all guests and faculty members and participants to join us for lunch. After faculty and staff members join the lunch, there are students are permitted. The lunch will be for an hour.